Even before we get started, I wish to quickly introduce myself and then we shall proceed further. Let me share my screen as well. I'm sure you're able to see my screen. Having said that, let me go and quickly introduce myself. My name is Bharani Kumar. That's me. Okay, and I'm an alumnus of IIT Hyderabad and Indian School of Business. And I'm also visiting faculty at Indian School of Business. I train the students of Advanced Management Program in Data Analytics or Business Analytics. AMPBA is what they call that program as. And I teach the students machine learning stuff and data science stuff. If you want to connect with me, here is my profile, feel free. But I think you'll not be able to connect, you'll only be able to follow me because I have reached the 30,000 connections limit, which LinkedIn has put. And I have 17 plus years of experience. I started off working with HSBC. Then I worked with Indian Tobacco Corporation. Then I worked with Infosys. And the last company with which I was employed was with Deloitte. And throughout, I've been working on data analytics, data science, etc. Right from the days when this particular profession was called as statistical programming, right since then. So once again, welcome to the session. This session is launched in collaboration with Task. And we are offering this program to the faculty members of Telangana region predominantly. And in this program, we will discuss about deep learning. And in the initial few days, it would be theory. We would understand machine learning primer, what is the difference between AI, deep learning, machine learning, what is the difference between data analytics, data science, data engineer, so on and so forth. And then we will get into math foundations, mathematical foundations to the extent which will help us understand deep learning. Only to that extent we will discuss. And then we will also do hands-on. After the initial 1, 2, 3 days of theory, it will be theory intense for the initial days. The reason being, when it comes to deep learning, there are a lot of terms, terminologies, language, lingo that one should be aware of. What do you mean by hidden layers? What do you mean by activation function? What do you mean by integration layer? What are the various optimizers that we have? What do you mean by backpropagation algorithm? What do you mean by gradient descent algorithm? What are the various loss functions, cost functions, error functions? What are the various regularization techniques? What do you mean by regularization techniques in the first place? So on and so forth. So our prime focus would be on these aspects, okay? And once we are clear with the various concepts, we will get into the practical zone of it. When I say the practical aspects, we would discuss about a specific use case. And once we understand the use case, we are going to use the algorithms that we would have discussed about, and we will practically solve it using Python. Python is a de facto programming language that we have. And also, we intend to cover end-to-end, okay, as opposed to just talking about algorithms and then stopping it there. We will also deploy the model in production. And we will also pull the data from one of the databases. So that is how we would traverse the entire journey. End-to-end is what we are going to focus upon. All right. So what are we waiting for? Let's plunge into action. But before I get into action, do you have any questions for me? Yeah, one more thing. Attendance is mandatory. Towards the end, we are going to post an attendance link in the chat window, and you will have to give the attendance. Okay, attendance is mandatory. I repeat that. Second, we will also have questions for you all, which will help you understand the learning. Okay, and those questions will be posted on a specific location. On WhatsApp group, we'll give that link. You need to go to that link and answer those questions, which will be based on the concepts that we are going to talk for that day. All right. Hopefully everyone is excited to get started. Do you have any questions, friends? Sorry, I would say doctors. Do you have any questions for me? If you have any questions, you have two options. One is resort to chat window, ask your question, feel free. Or you might want to raise your hand on Zoom, and then I'll unmute you and you can feel free to express your question. So I would just give a quick minute, and if there are no questions, then that means you all have given me a green signal to proceed further. And the sessions will be from Monday until Friday. It'll be from 2 p.m. until 4:30 p.m. And intermittently we'll be taking breaks because it'll be theory heavy and then practical heavy. Too many, terminologies would come your way. So it warrants for quick breaks intermittently. Towards the end session, the recorded session would be shared with you. So don't you worry on that front. And there are no questions, so let's get started. All right. So when it comes to deep learning, there are a lot of libraries which are available. Hey, what do you mean by library in the first place? Good that you're saying library, but what do we mean by library? Okay, let me explain here quickly, friends. Usually, when you hear this word library, what comes to your mind? Collection of books. So library is typically collection of books. And who has written these books? Some author. Some author would have written the books. And what do? We reuse the concepts which we have learned or we would have learned, right? This is exactly what we do. On similar lines, we have Python libraries. Okay, just a moment. I'd like to pull my image down here. Okay. So we have a lot of Python libraries. Python libraries contain code, which some programmer would have written in the past. What are we going to do as data scientists or deep learning experts or AI specialists? We are going to reuse the code. And to reuse the code, we need to be aware of two things. One is, what are the libraries? What are the needs of the libraries? And second thing is, how do I use that? For how do I use it? There are again two steps. One is, you need to install the library. Once you install the library, second thing is to use the code within that library, you will have to invoke the library. Okay, so we have Python libraries, then you'll have code within that, which some programmer would have written in the past, and we are going to reuse that. And also, Python is open source. When we get into Python programming, I'll talk more about that. I'll tell you how to download, way to download, what are the various IDEs like Jupyter, Spider, Google Colab. You have a lot of things. And we'll be using each one of that. Jupyter, for one use case, we'll use that. For another use case, we'll use Spider. For yet another use case, we shall resort to Google Colab so that we have a fair bit of understanding on each and every IDE. Okay, hope you have got a high level gist on what do we mean by libraries. And when it comes to deep learning, we have a lot of libraries out here. When we use Python, you have libraries such as PyTorch, you have Keras, you have TensorFlow, Theano, OpenCV, you have Caffe, you have MXNet, you have Microsoft Cognitive Toolkit, you have a bunch of libraries which are available. We would be predominantly making use of Keras, TensorFlow, and we shall also get introduced to PyTorch, and PyTorch is more or less becoming the de facto library when it comes to deep learning algorithms. A lot of people are, really keen to use PyTorch because PyTorch has the speed of TensorFlow and it has the ease of Keras. Keras is, okay, let me take it from here. TensorFlow is from Google, and TensorFlow is called as low-level programming language. Low-level programming language. Low-level programming knowledge means you need in-depth knowledge. Okay, you need in-depth knowledge to be able to write the program. But a lot of data scientists and deep learning experts started thinking that, you know what? We are not programmers. We are not here to build, web applications or mobile applications. We are here to solve business problems. Given this, can we have easier programming language, which any new person can learn easily? And then a person by name Francois Chollet has come up with Keras. Keras is high-level programming language. And after a few years, when Google has figured out that Keras is catching up the attention, whatever code you write using Keras, there'll be very simple lines of code. Whatever program you write there can be easily converted into TensorFlow code, and it can execute and give you the desired results. Hence, what Google thought is, okay, let us integrate Keras with TensorFlow. And from TensorFlow version 2.x onwards, 2.1, 2.2, 2.2, 2.3, whatever, right? 2.x upwards, Keras has become an integral component of TensorFlow. And we have PyTorch. Predominantly, it was developed by Facebook. These are all open source libraries, by the way. And PyTorch is low-level programming language. When you use low-level programming language, the processing will be faster. Very quickly, you'll be able to process. Okay, the algorithms run very fast. However, you have to write a lot of lines of code. You need to be a thorough programmer to be able to handle TensorFlow alone. Hence, we have Keras, which, you can write the program at a very high level. Even business users very easily can learn and start writing programming in Keras. However, the programming execution is slow. Why? Because this high-level programming in Keras that you write would convert the code into low-level programming language and then execute on TensorFlow itself. So that conversion part, etc., would take time. And when you look at PyTorch on the other side, it is obviously faster because it's low-level programming language. And the number of lines of code that you write or the programming language as such, the structure of which is as simple as Keras. So the ease of Keras, the performance, high performance of TensorFlow, both are part of PyTorch. So let me show you something interesting here quickly, and then I'm sure you're going to agree with me. And there is something called as Google Trends. I'm sure you all are aware of this. However, let me type PyTorch. So PyTorch, the demand for which is just skyrocketing. Let me take past 5 years data. Okay, that's how it is. And when you look at TensorFlow, while there are huge number of users for TensorFlow, the demand for both of these, is almost getting balanced out. And TensorFlow has been there since ages. If you look at 2004 until present, somewhere in 2015, people came up with TensorFlow. Okay, and somewhere around 2017 came PyTorch. But look at the way PyTorch has actually scaled up, and it's almost trying to compete with TensorFlow out there. But Keras obviously has a slightly lower market share. Okay, but then it's almost there, head on with PyTorch. Okay, so these are a few things that we need to be aware of. And OpenCV is used for computer vision applications. If our time permits, we will get into OpenCV as well. We'll try to solve a few use cases. So, yeah, Francois Chollet was the person who has come up with Keras, French mathematician. All right. First of all, even before you get started on any project, be it deep learning project or machine learning project or data mining project, whatever project you work on data, you need to be aware of the step-by-step process of handling the projects. First of all, we need to be aware of the project management methodology, the framework on how do we go about solving the business problem. And whatever you learn, either you learn computer vision or deep learning or machine learning, but whatever you learn, at the end of the day, we solve complex business problems. So we are solving business problems using our, AI capabilities. That's one thing which people have to be cognizant of. So there is this project management methodology called as CRISP-MLQ. CRISP-MLQ stands for cross-industry. CR stands for cross, CR. I stands for industry. S stands for standard. E stands for process for machine learning with quality assurance. Okay, ML stands for machine learning. Q stands for quality assurance. This particular framework called CRISP-MLQ has all these different phases that I'm showing. What are the different phases? We have business and data understanding. Okay, and we have data preparation. Then we have model building. Okay, and the other phases. Business and data understanding is the first phase. Okay, and as part of this phase, you understand what is the business problem. For example, say a specific, bank walks up, bank head of loan department walks up to you and says that, you know what, a lot of people are defaulting on the loan. What do you do? If a lot of people are defaulting on the loan, if that's a business problem, you record two things: objectives and constraints. You come up with the business objectives and business constraints. One of the business objectives for this business problem would be minimize the defaulters, because a lot of people are taking the loan and running away. They're not repaying. So you want to minimize the defaulters. At the same time, your bank might say that I also want you to maximize the profits. So minimize the defaulters and maximize the profits. Once you have these in place, you will have to define your success criteria. What do you want to achieve, right? In this, the very first point would be to solve your business problem. So you need to define your business success criteria. What do you think would be the business success criteria here? Probably you might say that I want to reduce the number of loan defaulters by 20%. Reduce loan defaulters by 20%. And once you define your business success criteria, the next thing is to define your machine learning success criteria. When it comes to machine learning success criteria, again, while there are many things such as you have to think about scalability, robustness, explainability, so on and so forth, there are two key things. One is accuracy. You might say that I'll help achieve an accuracy of greater than maybe 85%. Okay. Second key thing is performance. If you're building a model for credit card fraud, for example, there within seconds, within milliseconds, within microseconds, you should be in a position to predict. Right? The moment a credit card transaction is done, the moment you swipe it, you waive it, or the moment you do an online transaction, within microsecond, the prediction has to happen to determine whether the credit card transaction is fraud or not fraud. And if it is fraud, if there is high probability, high chance that your credit card transaction is fraud, then immediately you get a call from the call center. How do you think that happens? Because of the performance. So when it comes to performance, you might say that, you know what, I'll spill out the predictions in less than 0.1 seconds. So this is how you define your machine learning success criteria. Third, economic success criteria, very important. Be it your research projects, if you receive some grant, or be it projects that you do for different companies. What do they want at the end of the day is return on investment. If you receive a grant of $1 million, obviously the end benefit should be at least probably $5-6 million. So you need to define your economic success criteria, which is related to cost. How much cost are you going to save? Or in short, what will be the return on investment? For the money that I'm going to spend on the project, how much would I get back? Okay, this is what you need to define. Yep, Mr. Surya. You'll be able to unmute yourself. I think you have a question. You have raised your hand. I'm giving you the permission to unmute. Please, can you? Or did you raise your hand by mistake? Or are you not able to unmute yourself? In that case, you can use a chat window. But if you have raised your hand by mistake, then you will have to lower it. Yeah, okay. So this is the first phase of your CRISP-MLQ framework. And this is the framework which people use most often than not. If you want more details around that, I'm going to redirect you to a different forum where you can get more information about each and every phase. Then within this, you have something called as data understanding. It's business and data understanding. Until now, we only discussed about the business aspects. With respect to data understanding, you need to now go and collect the data. Okay, you'll have to go and perform data collection. And as part of data collection, you collect only that data which is needed to solve your business problem. If you go and ask the customer, say you're doing project for State Bank of India, for example, and they ask you to build a loan default prediction model, would you tell to State Bank of India that give me the entire data that you have? I, as a data scientist, or I, as artificial intelligence expert, would figure out what data is important. Would you say that? And do you think State Bank of India would give you the data? What do you think, friends? Can you please use chat window? What do you think? Let's play this role play. Okay, wherein suppose State Bank of India asks you to build a loan default prediction model. Do you think State Bank of India will give you access to the entire data and say, okay, figure out what data you need, and I'm going to give that to you? Would they say that? No, right? Absolutely, they won't say that. Then what they might say? They might ask you, right? They might say, please, can you give me the names of the features which you need? Tell me, give me the details on what do you need? What data do you need? What variables do you need, right? For that, while there are a lot of research forums available, one easy way out is to research on Google Scholar. Just go to Google Scholar, and if someone says build a loan default prediction model, you search in that. Okay, there are a lot of articles available. I'm sure as part of your colleges and universities, you must be having access to this. And once you read this, you understand on what data people have used, what variables people have used to solve the business problem out here. Then with that information, you go and ask your customer the appropriate data. Okay. And if the customer has data, customer would provide you that data. Okay, so data collection is very important. You need to do your groundwork, you need to do your research, and only then go and ask your customer on the variables that you need. But still, another question. This is probably a very important question from practical standpoint, because I'm coming from industry. I try to bring in the industry-oriented learnings. Do you think State Bank of India would download the data? Say you have done the research, either from Google Scholar or from your OPA. What does OPA mean? OPA means organizational process assets. OPE, organizational process assets. Every company, be it Infosys, TCS, Google, Microsoft, Accenture, whatever, when they work on projects, they save the data, the code that they have used, all the lessons learned, best practices, they would have saved that in their repository, and that's called as organizational process assets. If you're working with, for example, say Accenture, and if you want to do a similar kind of project, you go and first look into OPA to figure out whether you have done a similar kind of project in the past or not. If yes, go get that data. Okay, get that data and then start building on that. Why do you want to reinvent the wheel? Right. So that's called as OPA. Okay. The next important question that I wanted to ask is, do you think State Bank of India would download the data in Excel format or CSV format and then share it with you? Do you think they would do that? What do you think? What do you think? I mean, I'm expecting some responses out here on the chat window. Please feel free. No, right? No one would download the data in Excel format or CSV format and then share it with you. What would they do? They will create a table. They will take the data, put that in a separate table, tabular format, rows and columns, if it is structured data. And then they will give you access to that. And what should you do? Using your Python program or R or MATLAB, Stata, Weka, whatever you're using, you use that and establish the connection with the database. Whether you use IBM SPSS or whether you use SAS, doesn't matter. At the end of the day, you use that programming language and connect to the database. That is exactly what you will learn when we get into the practical application, when we understand the theory, and then when we get into the practical portion, we would look at the database, we would try to pull the data using Python, and then we will build our algorithm. That is what we need to do, right? So let me share the screen. So remember that from learning standpoint, that's okay, friends. But then when people go and attend interviews or when people start working on real-time projects, this is where there is a gap. When we ask people, okay, how do you get the data in Excel format or CSV format, or magically it flows and sits on my computer? No, it doesn't happen that way. You spend significant time understanding the business problem, defining your success criteria, and then you proceed further with data collection. And there are two modes of data collection. One is called as secondary data source, meaning if State Bank of India already has the data, and if you're just taking that data, right, you ask customer for the data and customer State Bank of India gives you access to that data on their database, that's called as secondary data. But if you need certain additional variables, which you cannot get from the bank, like State Bank of India, then you resort to primary data collection mechanism. What do you mean by primary data collection mechanism? Suppose you want data from the social media also. You want the data such as how many friends a specific customer has. Is this customer always writing about negative things on social media? Or is this customer also posting about positive things? What kind of emotions is this person exhibiting? Is this person always posting about latest of the gadgets? What do you mean by that? Is this person always purchasing new iPhone, new iPad, new MacBook, etc., and then posting on social media? In that case, would this customer prioritize purchasing a new gadget as opposed to repaying the loan? We don't know. We need to analyze. Is there a person who's always posting about international travels, partying? If yes, would this customer prioritize partying, international vacations over repaying the loan? We don't know. We need to analyze. So when you want access to that kind of data, that would not be available with State Bank of India. Then what would you do? You go and collect the data. Okay, when you go and now collect the data, it's called as primary data. Data which is already available as secondary data. Whatever be it, you ultimately collect the data. Once you collect the data, you'll have a lot of data preparation, which you need to do, meaning data pre-processing, which is also called as data cleansing, or data preparation, or data munging. There are multiple names. What all do you do as part of that? Let me quickly take your attention to the mind map that we have on our website. Here is mind map. Let me go to that. This is the data preparation phase. And data preparation is also called as data cleansing. Okay, data preparation, data munging, data wrangling, data organizing, all these mean the same. And here we have typecasting, handling duplicates, outlier treatment, zero, near zero variance, missing values, so on and so forth. All these are called as data pre-processing techniques. And once you do all these data pre-processing techniques, I mean, we would not get into all these trends because it's deep learning and AI training. If you want to learn more about these, then certainly I can redirect you to some interesting learning content of mine, but then that's what you do. And then you also perform something called as exploratory data analysis or descriptive statistics as part of data preparation, which includes first moment, second moment, third moment, fourth moment, graphical representation, all these kind of different analysis you are expected to perform. When we get into the practical aspects, I would teach you a few of the AutoEDA libraries which exist just by writing 3 to 4 lines of code, entire exploratory data analysis would be complete. Amazing stuff. I'm going to show you practically. Okay. In fact, we should do it today. Okay, the exploratory data analysis part, AutoEDA part, I'm going to showcase it today itself so that you understand the strength and the way the world is moving, the strength of analytics and the way the world is moving. Then you also have something called as feature engineering. Back to our discussion here. Let it come up. So business and data understanding, data preparation. As part of data preparation, you also perform exploratory data analysis. That is, you prepare the data such that it's useful for model building. When you get into model building phase, it should be useful. People should be able to build the models on your data. So here, data preparation is also called as data cleansing or data pre-processing or data munging, wrangling. All those are the different names. You also perform exploratory data analysis, which is called as descriptive statistics. And also, there's a small concept called as feature engineering. And a few of the data pre-processing techniques such as feature transformation, feature scaling, etc., are also part of your feature engineering. Okay, now, people say that approximately 60 to 80% of the time which people spend on entire project, out of the entire effort, 60 to 80% of the effort is spent on these two phases. And you know what? The irony is that people are getting trained are heavily focusing only on model building. What are the various algorithms? And they get into the nerves of each and every model to such an extent that they forget the very essence on why you need to actually build a model, not for fun, obviously, to solve a business problem. So without understanding the business problem, how can you jump into model building and focus heavily on model building aspects? Okay. Now there is a practical thing that we need to talk about with respect to feature engineering. Okay. Suppose there are 3 banks and all 3 banks have access to same data. They have access to the same data. Okay. And they have access to output variable, which is whether a person will default or not default, assume. And one input that they have access to is the debt. And another input is, say, income. So given income and debt, you need to predict whether a person will default on the loan or not. Bank A, let me call it as State Bank of India. Bank B, let me call it as Standard Chartered Bank. And Bank C, let me call it as HSBC. Say all these 3 banks have access to same data. Okay, they have, say, access to the same data. In this data, debt and income, the inputs are also called as features or inputs or dimensions. And the output variable is given a special name called as label or target. Target variable or label. When I say feature engineering, you take your inputs and do something with that. What is that something is what we are trying to understand. Okay. So here, say you have State Bank of India. If you are going to take the inputs as is, the way it is given to you by the customer, if you take it as is and build your model, you would get an equation like this. If you use deep learning neural network algorithms, you get an equation like this. Don't worry too much about the equation. We'll spend some time on that. We'll understand further. We have got 15 hours time. We did not even complete 1 hour. Okay. So please, just hold on. I've been delivering training for 9 years, very similar to your kind of experience. So I'm also slightly well versed with the flow, right? So I'm sure I'll do justice. Okay. So say State Bank of India has taken the variables as is and they built a model. Wonderful. Say people at Standard Chartered has done something else. Probably they would have combined these two into one variable and say they came up with a new variable, which is debt over income. Either income to debt ratio or debt to income ratio, whatever you want to call that. And this is the only input which you're going to use to predict whether a person will default or not. Instead of 2, you combine them into 1. This is called as feature engineering. Okay. So now, since you have a single input, when you build a model, you get an equation like this, W1x. So the good thing is, you reduced the model complexity. Rather than having 3 different calculations, you have only 2 calculations. So it'll be faster model, right? So you made it more efficient by combining these 2 variables into 1. Now let's take yet another example of HSBC. And this is a gold standard. This is how we need to solve. The raw data that is given to you by the customer is your number 1 enemy. You need to attack it. Okay. Don't spare it. The data which is given to you as is, don't spare it. Kill it. It's your number one enemy. And that is what we are trying to understand here. Okay. So say people at HSBC, okay, they might do this. They might say that, okay, we know that if we ask any economist, what would the economist say? Economist would say that income follows exponential distribution. Remember COVID-19? How were the COVID-19 cases? Initially linear, slow increase in the number of cases. After a while, there would be exponential increase. That's called as exponential distribution. And income as a variable follows exponential distribution. What does that mean? Majority of the people would either fall in low income group and middle income group. Only a small proportion of people would fall in high income group. Zuckerbergs of the world, Elon Musks of the world, these people are very rare. Right? Very small proportion of people would be extremely rich. This is law of economics. So it follows exponential distribution, and so is the case with debt also. Debt also follows exponential distribution. Ask any economist, they'll tell you, or ask any banker, they will tell you. So given that debt and income follow exponential distribution, we are expected to capture this exponential pattern. And to capture this exponential pattern, you need to take log of income and log of debt. When you take log, you would be able to capture this exponential distribution in a better manner. So instead of taking debt over income, you can say log of debt over log of income. When you use this variable in your model, so what did you do? You have taken your features, you have done some engineering with that. That's feature engineering. And now when you build your model, you get an equation like this. Y is equal to B plus W1X, but X would be log of debt by log of income. When you build a model like this, it will give you amazing accuracy. Hence, your data preparation is extremely important, and your feature engineering or feature construction is even more important. When people forget these aspects, and when people focus only on model building, only on the various models, that is when they don't get jobs. That is when they become irrelevant. That is what is called as a gap between industry expectations and academy, right? That is exactly what we will have to bridge. And this is how we bridge it. Okay. So once we are done with phase 1 and phase 2, you move to phase 3, model building. And while there are a lot of things such as supervised learning, unsupervised learning, reinforcement learning, self-supervised learning, semi-supervised learning, so on and so forth, our focus would be on data mining, supervised learning algorithms. Data mining or machine learning, supervised learning. Supervised learning is also called as predictive modeling. Okay, so you end up building prediction models. Once you build your prediction model, you will have to evaluate. Of course, we will spend a lot of time on this, so I'm just switching over here. And then you evaluate your model to determine whether your model is of good accuracy or not. Okay, that's called as evaluation phase. So you have phase 4, which is evaluation phase. I would control whether this animation should play or not, depending on what I'm teaching. Okay, so you have model evaluation. How good your model is, how accurate your model is. And in evaluation phase, we should also evaluate business success criteria, machine learning success criteria, and economic success criteria, which we have defined here. In phase 1, we would have defined business, economic, and machine learning success criteria. You need to evaluate all of those. It's not just model evaluation. You cannot say that I'm going to just look at the model accuracy. You might build a model with 98% accuracy, which is unfit for business, which is probably not useful for business. Then what is the meaning of spending so much of time if you cannot solve your business problem? Okay. Next, once you build your model, how would you deploy it? Let's go back to the same example of State Bank of India. Say you built a loan default prediction model. Wonderful. Again, question, right? So let's see. What do you do, friends, usually? Let me put it this way, rather than keeping it a close-ended question, I'll make it an open-ended question. Okay. Once you build your model, whatever machine learning algorithm you've built, once you feel that, you know what, my model is giving me the desired accuracy, say your model is giving you 98% accuracy, what do you do after that? How should, the loan department of State Bank of India use it? Are you going to share with them the code and say, hey, here is a Python code, amazing code that I've written, 1,000 lines of code, use it? Would you say that? We won't do that, right? Because we cannot expect State Bank of India employees to be well versed with Python programming, right? So what do you do then? How do you give it? How do you give your model to the end user? And trust me, friends, I work as a chief data scientist on 4 different companies. One is a US-based company, one is Malaysian company, and 2 are Indian-based companies. And when I conduct interviews, 99% of the people whom I've interviewed are clueless about deployment. Okay, where do you deploy the model? What do you mean by deployment? Clueless. All they know is machine learning algorithms, how to evaluate the model. And what next? You cannot give the code to the end user and say, hey, learn Python programming, run it. Right? So that is where deployment comes into picture. And that is what we will learn as part of this training also. This is what I mean by end-to-end. Right? It should not be half-baked, right? Half-baked is until evaluation, job done. After that, what happens? I'm not bothered. If you're not bothered, organizations who are going to hire you will also be uninterested to hire you, right? That is where deployment comes into picture. Deployment means you either build a mobile application or build a web application and let there be an interface or a business application. Let there be a screen wherein you are giving the State Bank of India employees all the fields: age, gender, education, income, loan category, loan amount, interest amount, etc. And let them click on submit button. And then they'll get to know whether a person will default on the loan or not. What is the probability of someone defaulting on the loan or not? Or from the database, the moment a customer applies for loan, online loan application, the data would come and sit in a database. Immediately when there is an entry in the database, let your machine learning algorithm trigger and show them the results on the web application or mobile application or business application. application. On that, let them take an action, whether they want to approve or reject. Now, you might ask me this question. Oh my God, do I need to learn mobile development, web development? Not needed. We have a lot of deployment tools which are available, and it just requires Python programming, very basic Python programming, and that's it. It will deploy the results. Once you deploy a model and once people start using a model, all these predictions, whatever predictions you have, say a new customer A has applied for the loan, online loan application. The moment those details go into the database, say your machine learning algorithm has predicted, once you get the predictions, write it back to the database, store it, record it. Why do you need to record? Because you want to monitor and maintain the model on an ongoing basis. The model that you build is not a one-time activity at all. It's not a one-time activity. It is going to be an ongoing activity. Okay, so you need to build the model and monitor and maintain the model on an ongoing basis. All right. So I'm hoping that the high-level picture is clear on how do you start the project and how do you ensure that it continues, right? You cannot stop that. This is an ongoing journey. Initially, when you build a model, maybe your model accuracy might be 80%. Then after 3 months, when you again retrain your model, accuracy might reach 90%. Again, it might reach 95%. Again, it might reach 98%. So it's an ongoing process. It's a journey, actually. Okay. And while you build a model, you frequently go back to data preparation phase. Maybe you missed out something critical. You might want to get that. Okay. And after your model evaluation, you go and check whether your business success criteria or machine learning success criteria that you define, whether you've achieved those or not. Overfitting and all that would come in model building. We would get there. Okay, still we have time. We would certainly get there. Okay. Now, another classic thing which people keep asking me is, hey, what is the difference between artificial intelligence, data science, machine learning, deep learning, text mining, NLP, a whole bunch of those? What is the difference? What is the difference between data analyst, data scientist, data engineer? Can you please explain me those? Oh, sure, absolutely. So, artificial intelligence, if you can automate it, or I would say human intelligence, if you can automate it, that's called as artificial intelligence. So let me explain that. So let me give you an example of human intelligence. If you're driving a car, what do? You apply brakes, you control the steering. If it's manual, you change the gears, so on and so forth. All these things a human is doing manually. If I can automate the human intelligence, then it's called as artificial intelligence. Simple. Human intelligence automated is artificial intelligence. Think about self-driving cars, autonomous vehicles, driverless cars. These are all examples of artificial intelligence application. UAVs, unmanned aerial vehicles. Okay. To build an AI application, you need knowledge about data science. And data science is a field which has data mining. Data mining is like coal mining, right? Like you dig coal. If you're lucky, you'll get precious metals like diamond, etc. And when you're digging data, when you're analyzing data, interesting insights like the diamond are very important. And that is what data scientists aim at. And when it comes to data mining, within that, you have a lot of sub branches, such as supervised learning, And then we have unsupervised learning. Then we have reinforcement learning. Then we have self-supervised learning, semi-supervised learning, bunch of these. But we'll talk about these three key things, okay? Within the data that is provided to you, the historical data, obviously your data would reside in some database. And in this historical data, if you have output variable and input variables, then it is called as supervised learning. This Y is called as output variable. And then you have X's, which are called as input variables. Inputs are called as features or dimensions. Output is called as target variable, right? Or a label. Then you'll have supervised learning, basically. Right? Supervised learning is also called as predictive modeling. Like predict who are the employees who will resign. Predict who are the students who might get a campus placement. Predict which of the credit card transactions are fraud. Predict who will claim insurance, so on and so forth. When it comes to unsupervised learning, you will have data, but within that data, you would have all the features, but you will not have your output variable. So the output variable is unknown. Even if you have it, you will start treating that as another input. For example, say State Bank of India has 20 million customers who have the bank account. And say State Bank of India want to launch a new credit card. And then if they send out emails to all the 20 million customers saying that if you use State Bank of India credit card and purchase new Apple iPhone, you get special 20% discount or 10% discount. When you send it to all the 20 million customers, and what if KTR is one of the customers? Or what if KCR is one of the customers? Or what if you have Narendra Modi as one of the customers, right? Then do you think they will really be concerned about 10% discount on Apple iPhone? Not really, right? So it is always better that we cluster or segment the customers, probably all the rich people, affluent people as one cluster, or probably all the middle income group people as another cluster or group, all the student community as another cluster or group. When you do these kind of clustering, you would understand to which segment you will have to send out this promotional email that if you purchase the new iPhone using State Bank of India credit card, you get a lot of discounts. So if you do those kind of things, there is no prediction out there. So it's unsupervised learning. For supervised learning, output is known. Then you have something called as reinforcement learning. Reinforcement learning means, think about stock market. A lot of people invest on stock market. And what do they want? They want more money. For the money that they've invested, they want more return on investment, right? So what do they want to do? They want to maximize return on investment. So they want more money in small sense. When they want a lot of money, or if they want investment, if they want to maximize their investment, then they will sell certain stocks, buy certain stocks, right? Certain stocks they will retain. Now, how many stocks should they purchase? How many should they sell? How many should they retain? How many different companies are trading on stock market? Every second, billions of transactions are happening. So those many rules, if you want to learn, or if you want to make your model learn, is difficult. That is where reinforcement learning comes into picture. When it comes to reinforcement learning, You just need to give a specific number, or you need to just say what it has to maximize or minimize, and it will do it for you. Let me show you one such example pertaining to reinforcement learning. Let me go here and let me show you that. Let me go to YouTube. Let me search as Atari breakout. Yeah, reinforcement. Just without ads, we cannot live. Had to wait, no go. Yeah, please look at this, friends. This is a classic example of Atari breakout, which is again an example of reinforcement learning. So the algorithm will play Atari breakout. And here you're not giving any sensory inputs. You're just saying that on the screen, you want to maximize it. And say you're training your model for 10 minutes. Let's see what happens. The only thing that you're saying is on the top, there are these numbers. You want those numbers to be maximized. That's it. That is all you're saying. And then this, scroller on the bottom, you're going to move it. You're not teaching how to move left, right, nothing. You're just saying maximize the score. If you train your model for 120 minutes, right, it will start playing like an expert if you use reinforcement learning. You didn't teach that, okay, you have to scroll left, right. You should not let that particular ball fall. You're not teaching anything of this kind. You just say maximize these points which are given here at the top. That's it. And if you train it for 240 minutes, it will do an amazing job. It did an amazing job rather as part of the experiment. Let's see. So it's digging a tunnel. If you see on the left-hand side, it's digging that tunnel. And the moment you dig, you know that very quickly you learn a lot of points. That is reinforcement learning. Okay. So within data mining, you have something called as machine learning. Usually people correlate machine learning to only predictive modeling, but it also comprises of the unsupervised and reinforcement learning aspects as well. Okay. And within machine learning, within this machine learning, okay, let me wait for that to come up and then I'll pause it here. Within machine learning, you have a special branch called as deep learning. And this program that we have is about deep learning. Right? When we say deep learning is synonymous to neural networks. Neural networks. Okay. And within deep data mining, we also have natural language processing. Okay, text mining, etc. But nevertheless, no matter what you do, at the end of the day, you end up building an AI application. Okay. Having said that, there is yet another doubt which people ask me, and or a lot of people have this doubt on what is the difference between data analytics, data science, and data engineering. What is the difference? This is one classic question which people keep asking me. And before I answer that, like a suspense, right? We'll take a break and come back. I'm sure a lot of you all want that. A few of you all have sent me a private message saying that, can we have a quick break? Yeah, sure. Why not? So the time now is 3:13. Can we all be back by maybe 3:25? Or, yeah, I think that should be a fair number. Okay, let's take a break and let us be back. Thank you all so much. We will pause the break, take this discussion further. Welcome back. And we should take this discussion further. So we now covered some ground with respect to the methodology, right? We are talking about CRISP-MLQ, which is a project management methodology in which we have business and data understanding. This is phase one. We have already spent time. In business understanding, you understand you'll have to record the business objectives and business constraints. And you also need to record the success criteria. Okay, we have business, ML, and economic success criteria. Once you're done with that, you go and collect the data, which is needed to solve your business problem. As part of data collection, you have primary and secondary data sources. Then we prepared the data. You need to pre-process the data. You need to clean the data. You need to pre-process basically. And alongside that, we also perform exploratory data analysis or descriptive statistics. And you also need to perform feature engineering. Of course, we discussed about feature construction. And we then supply the data to the model. You build a model, evaluate. When you evaluate, it's not just the model evaluation. It's not just the machine learning model evaluation. You also evaluate to determine whether your model is meeting your business and economic success criteria or not. And then you deploy a model in production. After deploying your model, you continuously monitor and maintain the model. Okay, that is very important. It's not a one-time task wherein you build and forget about that. It has to be an ongoing process. And if you want more details in each and every phase, then I would recommend you to access this mind map point number 1. And if you feel that, no, we want some additional information, additional insight, then I can always redirect you to this particular post of mine, which has an animation in it to explain about CRISP-MLQ. Let me redirect your attention to that. And come on. So you would very, very clearly understand the additional steps which are needed. Let me get there. And let me give you that access to that post, because that's an amazing post, friends, and it has garnered a lot of eyeballs. That in itself is a proof that it's adding some value. So I thought I should certainly share that with you all. This is all about model building, model deployment aspects through visualizations. It's not moving. Okay, I'm not purposefully stopping there. So just give me a minute while I take your attention to, or let me pause it and quickly scroll it and go to this particular slide or post where I have the CRISP-MLQ stuff, which is very neatly explained. And getting there almost. There are far too many posts that I've been doing off late, so let me get there. I'm almost there. Yeah, got it. So this is a thing that I wanted to share with you all. And let me also open that and share my screen. So this one. Okay, a lot of people have liked it because this gives you a lot of additional information on what we do as part of each phase. While I've tried to help you all understand a few things, obviously this in itself is an 8-hour session that we usually conduct. Okay, and if you want access to this post, I would share it with you. There we go. You can also bookmark and keep it if you feel that it's going to help you. Okay, back to our discussion now. So we have to talk about the differences between data analyst, data scientist, and a data engineer. So no matter what you are, who you are, right, at the end of the day, I mean, from the project standpoint I'm talking, right? No matter which role you play, you would have access to data. And once you have access to historical data or the past data, then if you are a person who would analyze on what happened in the past until present, okay, what happened in the past until now, when you take your data and try to understand that, then you'd be called as a data analyst. For example, did the sales increase? Or did the sales decrease? Or was the sales remaining constant? What was happening to your sales in the past until now? When you create these kind of reports and dashboards or some kind of analytics, if you do on the past data until present, then you would be called as a data analyst. And the profession that you work would be called as data analytics. And if you talk about future, if you predict on what might be the sales in the future, what would be your sales for the next 1 month? What will be the sales for the next 1 year? What will be the sales for the next 1 quarter? Whatever be it, if you talk about future, then you will be called as a data scientist. And the profession that you work would be called as data science. Okay, then as a data scientist, you are also expected to know on what happened in the past. It's not that you are going to be blind towards what happened in the past until present. As a data scientist, you also should be aware of what happened in the past until now. So I would say this entire thing is important for you as a data scientist. While working from past until present and creating reports and understanding on what happened until now is predominantly the job of a data analyst. As a data scientist also, you should be doing that alongside predicting the future. Then what about data engineer? Okay, so data analyst does this job, data scientist predicts the future. Then what about a data engineer? What does a data engineer do? Right, you need to answer that as well, that aspect as well. For that, once again, I will redirect your attention towards one of the model deployment strategies, just to help you all understand how the deployment happens. Okay, so here we go. I'm getting to that. A location where we have, again, a visualization to help you all understand the deployment. There we go. You have to just give me a moment. Okay. I have it somewhere here up in my post, so I'll open that. Right. Is it not opening? Yeah, there we go. So this is the model deployment aspect, friends. So what does a data engineer do? Data engineer will establish the connection between different data sources to your database. So you will have data from social media, you'll have data from IoT devices, data from various web sources, data from flat files. All of that will get into a database. Once all that data goes into the database, from there, you need to pull the data into Python, perform the data pre-processing, get the data ready for model building. Then you proceed further with model building and model evaluation. Then you deploy that model onto some kind of an application called Flask. From there to something called as Docker. From there to cloud environment, Amazon Web Services, Elastic Beanstalk. Then you deploy it to the end user. Right? So that part is extremely important. And if you want access to this, okay, then I would give you the link pertaining to this as well, which very, very clearly, right? When you have visualizations, it's easy for you to remember and what's the job of different people. So data engineer establishes the connection between all those applications to the database, database to Python, Python to model deployment, from there to the end user. Establishing all those connections is the job of data engineer, but which would be, my best take is that you have to be a little programming intensive to get into the role such as data engineer. No matter which role you perform, you should be aware of deploying your solution in production. Without that, there is no job, period. Because AutoML is picking up in a big way. Okay. I would, towards the end, probably 15-20 minutes or half an hour, I'd explain about Python programming a bit. And I'll also draw your attention towards AutoEDA techniques, right? I still have some time left. So within that time, we would certainly, what is this? Reply to Shanu. I didn't quite get you. Someone is sharing some files. I don't know what is that. Okay, by mistake. Okay, sorry. I thought it's for me. Okay, let's focus on the training part, right? Okay, anyways. So when it comes to stages of analytics, the first stage is called as descriptive analytics. And that is, you take your historical data and then you think about or you talk about what happened in the past until now. That's descriptive statistics. What happened? Did the sales increase or decrease or stay constant? The next part of descriptive analytics is diagnostic analytics, meaning why something happened. Descriptive statistics analytics is fine, but if you want to talk about why something happened, then that's called as diagnostic analytics. Why did our sales increase or why did our sales decrease? Why is it that the sales is remaining constant throughout? That's part of diagnostic analytics, why something happened. And then you have predictive analytics. Predictive analytics is what is likely to happen in the future. Okay, what might happen? What will our sales be at $1 million or $2 million, or will it be anywhere between 1.5 to 1.8 million dollars? What would be the sales in the future? Is predictive analytics. So descriptive and diagnostics is all about past. Okay, what happened in the past? Then you also have prescriptive analytics, which is what is to be done. Predictive analytics will talk about future, but then based on that prediction, if the prediction says that your sales will be below your expectations, below your target, then what would you do? What is it that you have to do? Should you increase the number of human resources? Should you increase your marketing spend? Should you do more of branding activities? What should you do? Is prescriptive analytics. So these two would talk about future. So you have the past and you have the future. Next. A few applications before we proceed further. This is a preventive maintenance project which we have done for one of the largest beverages company on the planet. It is anybody's guess. Okay. So here, there is a manufacturing plant, and this manufacturing plant has a lot of machines. And all these machines have sensors like temperature sensor, humidity sensor, right? Height sensors, so on and so forth. Through those sensors, you get the data. Okay, you get the data, and using that data, you can actually predict whether that machine will fail or not. So the data that you're getting from the sensors, these sensors are also called as IoT devices, Internet of Things. Any device which connects over internet is called as Internet of Things. So it would give you the data of temperature, chiller, that is also vibration sensors, sound sensors, because if the machine is doing a weird sound, it might fail. If the machine is vibrating a lot, it might fail. So you need all these sensors. To that, you get the data, and based on that data, you predict whether a component will fail or not. Okay, which component will fail? Which machine will fail? And not just whether a component will fail or not, but you can also predict when will it fail? When will a component fail? If the prediction says that, hey, this machine, this component will fail in the next 2 hours, then you can send an SMS to your technician, and your technician can quickly come and fix the issue even before it fails. Right? So this is exactly what you can do given the data. This is called as preventive maintenance. Even before your machine fails, you predict and take a call. Then this is a specific project which we have done way back in 2017. Now we are in 2022. 5 years back, we have built this model. And we won the first place across India for this project in Project Management Institute National Conference. So this is all about if a vehicle is moving from, say, Hyderabad to Bengaluru, and if this vehicle breaks down midway, if it fails, stops because of engine malfunction or whatever reason, then a lot of people will be negatively impacted. Driver, truck owner, the person who's expecting the goods, person who has sent you the goods, and a lot of people. And if your vehicle is in warranty, what do? You call the call center. You'll say, hey, vehicle broke down, come fix it. So the original equipment manufacturer has to send the technician. Technician will either fix it there or take it to the service center, fix it. It's all waste of time, money, effort. So it's warranty cost to OEM. Also, if your vehicle is under insurance, you'll claim insurance. So it's insurance cost to the insurance companies. So what we have done is we have placed IoT devices called as ECUs, electronics controlling unit or telematics controlling unit. And we started getting the data of 196 components of the truck. And using that data, we started building prediction models. We predicted whether a vehicle will break or not. Firstly, will a vehicle fail or not fail? If it is going to fail, after how many kilometers will it fail? and which component will fail. All of these things we could figure out. Sure, Sridhar. Towards the end, I'll show. So this is yet another application of AI. Then this is a smart factory which we contributed to. It's for Malaysian client. Okay, wherein the moment you enter the hospital, you can capture the key components of vital components of your body. And then when you stand here, using the facial recognition, it will recognize who you are, and it will also bill you. After the doctor's consultation, you can directly walk here. And then here, if you stand, it would capture your face and it would dispense the medicines directly. No human is involved here. The only place where a human is involved is when you and doctor talk to each other. And the doctor would wear a Bluetooth device and the entire conversation is recorded and placed in a database, such as the patient name, what were the symptoms, what were the medicines suggested, all that would be digitally recorded. Imagine what happens in India. You go to one hospital, prescription is given, you throw it somewhere. When you go next time, you go to a different hospital, to a different doctor, and your entire history of diseases is gone. Through this, data can be captured and then a lot of analytics can be performed. While I was there in this experience center, I was experiencing, because we built some component of AI into this. So that's me actually. It's not clear maybe, but yeah. Next, supply chain. Within supply chain also, you can heavily use AI. When you want to assemble one flight, you get the fuselage from one location, you get the cockpit from another location, you get the engines from another location, you get the landing gear from another location. From different countries, you get the different components, different companies manufacture it, and then you assemble that. Predicting whether there will be any delay in manufacturing of aircrafts is extremely critical. It is extremely critical. I'm not sure. Is this a call from someone, faculty or task? I'm not sure. Just give me a moment, sorry. Sorry, I take the calls because sometimes faculty or someone, probably they have issues and they might call me, right? So fine, that was another call anyways. So you can do all those predictions. And do you know what? Amazon has done an amazing thing in terms of using AI in their supply chain. Rather than you book a product and then the product will be delivered to you, rather than taking that route. That's what happens, right? On Amazon, you go to Amazon, you order a product, and then Amazon will ship that to you. What if that product is in a different state or in a different country? By the time it reaches you, it will take huge amount of time. So Amazon has come up with an algorithm which is called as anticipatory package shipping. Way back in 2013, they filed for a patent, 2013. And that model would upfront predict on what are the kind of products which people will order in Hyderabad region, for example. What are the kind of products which people will order in Bengaluru? What are the kind of products which people will order in Delhi? What are the kind of products which people will order in different locations? And based on that, they used to upfront ship the products to that location. even before someone places an order. So how good should your prediction model be, right? And then what happens? Products will reach you very fast on the same day. You place an order, you get the product. Wouldn't you be happy as a customer? Absolutely, I bet you would. And these are the kind of applications which are ruling the world of AI. In this way, there are huge number of applications, huge number of use cases. Then I would like to skip a few as opposed to going on and on with the use cases. Okay, and I wish to take your attention to some more theory. As I've told you, initial 2 to 3 sessions will be very heavy on theory, and then I'll certainly get into the practical portion. But I think it warrants that we get into some amount of theory. So before I get into the theory, let me tell you that we will be downloading 2 softwares. You will have to download Python and you'll have to download Anaconda for your practice. You need not do it in class, but download and keep it. Post the session, you can start accessing. Python is free. It's open source. For whom? For individuals like you and me. And even if companies want to use it for commercial purpose, it is free. Gagan, it is until 4:30, right? So we shall share it towards the end, that announcement. Okay. And Anaconda is free for individuals like you and me, but it is paid if you want to use it for commercial purpose. That means when companies use it, not-for-profit companies, other than not-for-profit, when they use it, for-profit companies, they need to pay the license. You might ask me, what is the difference between these two? And why do I even need Anaconda, right? So let me also briefly explain about that. Python was developed by a person called as Guido van Rossum. Guido van Rossum was a founder, he's the founder rather of Python programming. Way back in 91 time frame, they launched Python programming. But very soon people realize that when you download Python, you have to manually install the required libraries. Manually, you need to install the libraries, Python libraries. And in the due course, people were encountering a lot of errors, such as this library is incompatible with this Python version, right? So on and so forth. And we as data scientists should spend more time solving the business problem. Okay, you will have to solve all those errors that you get. That's not our job. Our job as data scientists is to solve the business problem. Hence, you can download Anaconda. If you download Anaconda alone, it is good enough. It will do the trick for you. Anaconda is a company, and people working in Anaconda, they have taken Python and they have already installed all the most widely used libraries. And even if you want to install a new library which is not part of Anaconda, then it's very, very easy. It is compatible. You'll not get any version errors. This version is not compatible with this version of Python. You won't get all those errors because they have already done the due diligence. They have already fixed all such issues. And hence, people prefer Anaconda over the core Python. But either you write the code in your core Python or anywhere else doesn't matter, friends. It really doesn't matter. Okay, so let's go here, and all you need to do is just say download Python. Nothing else. Just type download Python. And the first link, the first URL that you get, click on that, and you get to see this. Okay, here, when you click on download Python, you'd be able to download the latest version. That's fine. Okay, so Python is operating system agnostic. What do you mean by that? You can install Python on Windows or Linux or Macintosh. It doesn't matter. You can download Python on any of the operating systems. Okay, the moment you click on this, a file will get downloaded. Install that. And after installation, when you open Python, okay, this is what you get. This is how the screen would appear. And you can start typing 1 plus 1. When you enter, you get 2. Simple. 8 multiplied by 3. Enter. You get 24. Okay, so this is how you use. And if you want to download Anaconda, just say download Anaconda. And the first link that you find, you click on that, and you'll get Anaconda distribution. You click on download. And Anaconda also is operating system agnostic, meaning you can download Anaconda on Windows or Macintosh or Linux. It doesn't really matter. Okay, it's like petrol. Petrol can be filled in Honda City or Honda Civic or Toyota Corolla or any other car, Maruti Swift. In any vehicle of your choice, you can pour petrol, right? So Anaconda is like that. You can install on Windows or Apple or Linux. It doesn't really matter. When you click on this, you'll download Anaconda. And once you download Anaconda, if you launch Anaconda Navigator, remember there will be an icon like this, green icon pertaining to Anaconda Navigator. Open that. And you would get Anaconda Navigator. It would take a while to open because it's a heavy application. And let me see whether, yep, it's launched. Here we go. So within this, you will see a lot of names. Don't be puzzled. Don't be surprised. Not needed. These are all, whatever you're seeing here, are called as IDEs. Integrated Development Environments. And each IDE will have a different GUI, graphical user interface, in which you have Jupyter, you have Spider, you have PyCharm. All of these will have different look and feel, different IDEs, okay, have different graphical user interfaces. Now, if I click on Jupyter, for example, and click on launch, if it says install, you click on install, it will get installed, and then you can launch it. If I launch it, this is a kind of interface that you would see. In the new here on the right side, do a drop down and click on Python 3. You would not find SageMaker because it's something that I've installed separately. But when you say Python 3, it would open the screen. It's loading. And then here you can type 1 plus 1. Okay. And then do you see this option run? When you click on that, you get to see the result. 2. When you say 3 multiplied by 4, when you click on run, you get to see the result as 2. Next, let me launch Spider. Everything will do the same thing, same job. Like either you use Uber or Ola or Rapido, it doesn't matter. Ultimately, you'll go from one location to another. Use either Spider or Jupyter or PyCharm or Google Colab or Core Python, doesn't matter. Ultimately, you'll be able to execute your programs. That's it, simple. Okay, when you open your Spider for the first time, you'd see a slightly different interface, but I like this interface, which is when you go to View, Windows Layouts, do you see our Studio layout? That's something that I like the most. So when you click on that, you would see this kind of an interface that's currently appearing. So here you can say 1 plus 1. And do you see an option here just underneath the tools? If you click on that, it would say that the output is 2. This is how you run. If you feel that, no, I don't want to install all these things, Barney, do you have a better solution out? Yes, absolutely. Just go to any of your browsers, type Google Colab. When you type Google Colab, you would have this. Let me click on Google Colab here. Okay, and you can click on New Notebook, and then you will get this. You can start writing the code. Okay, you can start writing the code right away. Here, if I type 1 plus 1, for example, for the first time, you will have to, okay. I'm not sure whether you're able to see that or not. Let me see on how it's appearing, because on the right corner, my image would appear. I would rather close my image and then explain you this part if it's not appearing. Okay, let me shut down my image for a while. So here you will have an option called Connect. You will have to click on Connect. And the moment you click on Connect, Google will allocate one of the servers free of cost for you. Okay, so let it come up. Yep, it has allocated. Now we can start typing. When you type 1 plus 1, click on Run, you get the answer as 2. When you type 3 multiplied by 4, for example, and click on Run, you get the result as 12. This is how you can proceed further. Now let's get into the AutoEDA. Duration of the session will be from 2 until 4:30. 2 to 4:30. Yeah. I think Rajita has already shared that. Okay. Now let me help you all build AutoEDA tool. It's going to take just a quick minute for you all to learn that. It is not time consuming at all. Okay, so let me first take your attention to something called as a SweetWiz application. If you may just allow me a quick minute, I would resort to Jupyter, and then I'm going to explain you on that. How simple can things get, right? That's what I'm going to explain. Okay, let me share the screen. These are the only lines of code that one should be aware of. That's it. 1, 2, 3, 4, 5, 6. And your entire exploratory data analysis is done. That is the reason why your focus should be on the concepts as opposed to writing the lines of code. Sorry, I need to keep sipping hot water. Okay. So there are a few libraries that one should be aware of. Let me write it down here. For your deep learning or machine learning purpose, there are a few libraries that one should be aware of. One is NumPy. NumPy is used for numerical calculations. Then you have SciPy, which is used for scientific calculations. Then you have Pandas, which is used for data manipulation purpose. Then you have stats models, which is used for statistical analysis. Then we have sklearn or scikit-learn, which has machine learning libraries, machine learning algorithms in that. Then we have matplotlib, which is used for data visualization. Then we have Seaborn, which has advanced data visualization aspects. Then we have TensorFlow, Keras, PyTorch. These three are predominantly used for deep learning purpose. There are exhaustive number of libraries which are available apart from these. We have Bouquet, Plotly, etc., which are used for visualization purpose, feature engine for feature engineering purpose, and bunch of other libraries. But to get started, these are a few libraries that one should be aware of. Okay. So, given that these are the libraries that one should be aware of, let's proceed further. So, what did I say? I told you that when you download Anaconda, a few of the most widely used libraries are pre-installed. Okay, they will come along. Like when you get married, your in-laws, relatives, everyone will come along as a package. In that way, when you download Anaconda, you get Python and all the required libraries. If your library is already installed, you need to invoke that. Okay, how do you invoke it? By running this line, import pandas. You can just import pandas and leave it there. And then type pandas.read_csv. Or you can import pandas using a shortcut as PD or as AB. If you give AB, you have to say ab.read_csv. Since you have given PD, you're saying from this pandas library, which is loaded as PD, read the CSV file. So I'll run this. Okay, so we imported pandas. From pandas library, we are trying to pull this or use this function called read underscore CSV. So let me write it down here. So from this library, we are trying to get this function called read underscore CSV. And within the double quotes, you are giving the complete path of your dataset along with the name of the dataset and extension, along with the dataset name and extension. And using this assignment operator, you are assigning it to an object or a variable called df. Okay, within that, you'll have the entire dataset loaded. You're storing in that. So let me click on run, and this also got executed. All hunky-dory until now. Okay, next. There is a library which is AutoEDA library, which is called as SweetWiz. Okay, SweetWizard is an AutoEDA library. So you say exclamation pip install SweetWiz. This is a syntax that you need to use when it comes to Jupyter. In Spider, etc., you just say pip install SweetWiz. Even without exclamation mark, it works for that case, right? If you want to install, that's how you run it. But for me, it's already installed, so I need not run it again. So I'll add another line, and I'm going to import SweetWiz as SV. I mean, even if you don't give this as SV, it doesn't matter. So what would happen is, within SweetWiz, there is a function called as analyze. If you just say import SweetWiz, then do you know what? This line of code, you should write it as SweetWiz dot analyze. Okay, SweetWiz dot analyze. So rather than give the entire name, what are we doing? We are importing it as SV. Hence, instead of writing this entire SweetWiz, you're just saying sv.analyze. Isn't that simpler? Yes. That's the reason why we put that. And you're saying sv.analyze on this df. What is this df? df is this dataset. This dataset is there on version 2 slides dataset. So let me go here. Version 2 slides in datasets. I have this education dataset. Let me launch that and show you what is contained in this. This education.csv file has data serial number, work experience in months of the students who are joining this B school, along with the GMAT score. These details are available. And that is what you're loading in this DF, right? So all I'm doing is I'm taking this path, this entire location path, copying that and pasting it here. Okay, but remember one thing, you also need to give the name of the file and extension. Okay, and when you load it, for example, this is how the path will be in double quotes when you paste. But here, one more thing is you need to give the name of the file. All right, so what is the name of the file? Education.csv. So let me type that also. But this backward slash won't work. So you need to change that to a forward slash. like this. You need to change that. Fanu, just understand that we need to change. There are a lot of shortcuts which we'll understand eventually, right? And then you need to run it. Once you do that, the data, this data, all these 3 columns data would get stored in DF. When you say sv.analyze of DF, it will analyze the complete data and it would perform what is called as exploratory data analysis. The first moment business decision, it will calculate mean, median, and mode. It will calculate variance, standard deviation range, skewness, kurtosses, a lot of graphical representations. It will do all of that. And it would save the details in S. When you say s.show HTML, HTML is your web page. So you're saying display all the results on the screen. So what are we waiting for? Can we execute it? Yes, let me run it. So here you see that symbol loading, it's analyzing. And then there we go. Complete analysis is performed, right? Associations is called as correlation analysis. For each and every variable, for example, your work experience, what is it doing? Do we have any missing values? No. What are the most frequent values? What are the smallest values? What are the largest values? Okay, what is the distribution, histogram? You can make out multiple things from that. You have here, how many numbers do you have? How many distinct values you have? What is the maximum value, minimum value, median, average or mean, standard deviation, variance, range, interquartile range, skewness, kurtosses, summation, whatnot. All these on a click of a button. Okay, so that is why I keep telling to people that the field of AutoML and the field of AutoEDA, automating, is working in a very big way. But we as data scientists or AI experts should understand how to interpret those results. For example, here you got a kurtosis value of 13.4. So what? What does that mean? You got a skewness value of 2.6. So what? What does that mean? Until and unless you answer those kind of questions, it would be meaningless. These numbers would mean nothing if you cannot blow life into these. Okay. Yeah. Attendance. A lot of you all are keen about that. Okay. So that's the AutoEDA aspect. I'll show you one more AutoEDA and then I'll do a recap and then we'll wind it up. Okay. So just give me a quick moment while I bring up another amazing AutoEDA technique, which is called as detail. Okay. There is another AutoEDA library, which is called as detail, not DETAIL, detail. That's how they have named it. So this is also something which is already installed. If it is not installed, may I ask this question for people who are attending? Can you type in the chat on how do you install the library? How do you install detail? Pip install, what is the name? Give me the complete name, please. Vignan Surya, you're right. Yes. Chandrasena. Yes, you are right. So what you do is you say pip install detail. Let me write it. Let me add another line. So you say pip install detail, right? And then you need to run that. Once it is installed, how do you import it? Using detail. And here you're saying detail.show of df. df contains your dataset. Education.csv, that is there in df. Detail.show of df, you're storing that in D. And when you say d.open browser, you get to see the results. When you click on run, the star mark here says that an operation is in progress. The moment it is complete, it will show in the browser, in your web browser, it will show the results. So the star mark means operation is going on. Now it has accomplished. Here, do you know what amazing things can be gleaned? You must be wondering, hey, it's the same data, that's it. No, when you hover here, you have actions. You have visualize. Okay, you can look at describe. You know, it gives you the box plot. You can look at histogram. You can look at the values. I mean, for this, it doesn't make sense, but for work experience, describe, histogram, do you want the probabilities alone or do you want the frequencies? Value and counts, and then you have QQ plot, which checks whether your data are normally distributed or not, and bunch of things. Hey, do I have outliers? If yes, what are those? All these, just like that. Click of a button and you're done. In that way, you have multiple things. You have in visualize, you also have correlations. You get the correlation details. You can find the correlation between two variables and bunch of things, right? So that's the beauty and strength of the AutoEDA techniques. So a quick recap, and then I'll explain you about a few things, and then we can connect tomorrow. So we started talking about CRISP-MLQ framework, which has 6 phases. Phase 1 includes business and data understanding. Then you have data preparation. Then you have model building, evaluation, model deployment, monitoring, and maintenance. We have done an overview of these. While our focus will be on neural network algorithms from tomorrow onwards, I wanted to give a high-level gist of how the projects are handled end-to-end in real-world settings. Then we have switched the gears to understand a few elementary things about Python. And we have just executed a few AutoEDA libraries just to get a hang or feel on how Python programming works. Okay, and tomorrow we are going to talk about math foundations, and we will get into deep learning primer. Okay, we'll talk about deep learning primer. Post this, it will be one algorithm, one neural network algorithm every day, followed by the practicals, plus the practical implementation, meaning we will take a specific use case, we will build end-to-end, mind you. We'll take a database, we'll pull the data, we'll build our algorithm, we'll deploy it, and all the predictions, we'll write it back to the database. So end-to-end, we'll do it. Trust me, no one is going to explain all those aspects. Okay, so we would be looking at end-to-end application. No, PPT, PowerPoint presentations, I'm sorry, cannot be shared. Okay, however, the recorded videos, we will post in the WhatsApp group. The moment the video is available, we shall notify you. Okay, and you will get access to that. The datasets will give you access to that. The code that I'm going to run, we will share those details with you. Okay, the link would be put on the WhatsApp group. From there, you click on that and you can download. Code, data, and the videos, recorded videos will be shared. PowerPoint presentations, I'm sorry, I might not be able to share because it has a lot of animation, a lot of hard work went into that. We want to retain it at our end only, right? Okay. Any questions for me? And also there will be some quiz questions which we'll post. We request you all to answer the quiz questions. Anything that you want to ask, feel free to ask, please. Or any suggestions, feel free. If there are no questions, then thank you so much. Attendance link is shared. You might want to give your attendance and then we can proceed. Yeah, there's a curriculum for the next 7 days also, Vignan, which is already shared, I believe. If not, we can share with you. Okay. Thank you. Thank you so much, Wasim. Yeah, I'll share the link on, I would suggest any day install Anaconda. Yeah, sure, Usha, we shall do that. Thank you and have a great day. We'll connect tomorrow and take it forward. Thank you, Chandrasena.